Okay, so for today we are going to talk about PKTOOLS, but before to go in this direction, there was one there were two assignments. One was from the previous lecture, or the one from AWK, and the second one was more following up with a video lecture from last year, presenting the multi-core operation in GDAL, using Bash and GDAL. Okay, so I will give the words to Saverio, but before I want to point where this, just in case someone didn't find it. So you can find, share. Okay, you can find in the docs, like always, you go to the syllabus. You go to the syllabus of yes, and you're scrolling down over here, you can find the web page that is pointed to the video recording. Okay, so this one, okay? So now Saverio is going to mention and explaining what this tutorial is teaching you guys. And then I will take the word. So over here. To you,
Okay.
Saverio.
Yeah, I will share. Okay. You see?
Yeah.
Okay.
Perfect.
Going on media, SF3, Jupyter. Okay. I follow like the video and I try to apply the codes. Also like reading a bit of how Xargs works. And I do like Jupyter, a Jupyter like a page with code like explanation and of the code. I tried to working on a single image, and I use like GDAL as we seen in the previous lecture, how to split the GDAL, the single image with GDAL in slices. In this case, the first image was like a DAM, not so big, but just for like for trying the code, and it works. As soon as I start, okay. Maybe. Okay. So I start like calculating the
Saverio,
sides.
sorry.
Yeah.
Can you show also, before to starting, the default of the virtual machine is when you set up, it was using only one CPU.
Yeah. Okay.
So if you go
Yeah.
into the setting,
Yeah. H-top.
no, apart of,
Oh,
if you
okay.
go into the VirtualBox setting, you can show machine setting on the top.
Yeah.
No, yeah,
Machine
input,
setting.
yeah, imposter setting, impostazioni. Yeah, and then you go system.
Yeah.
Then over here, processor. Over here, you
Yeah.
can increase the number of processors, but
Yeah.
your virtual machine need to be shutting down. Okay,
Yeah.
so you
Yeah.
have to shut down the machine, then increase the CPU, and then boot again.
Okay. I put like one before the red, like the red margin. I stay as 3. I don't know if it's good or not. 3 CPU.
Yeah, 2 CPU. I mean, for the example, it's fine even 2.
Okay.
And just
Okay.
to understanding how it goes and the multi-core implementation.
Okay.
Go ahead.
I set up the H-top, like using for monitoring the activity of each processor. And maybe I will like size down. Sorry. Okay, this one I can. Okay. And then this case, I want to like calculate the sides using IWK, just catching the sides of an image of the chosen image using IWK, and then I do the splitting. So I use like GDAL translate. I need to pass like the width, the height of the image, and to having an half, and assign these sides to each parameter that are shown here. So we like the this kind of parameters for the GDAL digital translate. We have the x of, so like the pixel size of the x coordinate and the y side of the coordinate, and then the total side of the window. And so I put them here with the halved sides where I should create the splitted window. So the top left I changed mainly. Then I create, in this case, the four slice of the single DEM I used to. Then I try to the multi-core processing. The multi-core processing is like using these xargs command that is sent before the for loop, and it specify the argument. The number one is like the n1 is the argument, sets like the number of elements that will be computed by each processor, and the number of processors involved into the xargs like function in this sense. Then I set up like the file. I call the file, and then I try to do an operation. In this case, after like the whole settings here, this part, this is like the operation. And the operation, in my sense, was like creating the slope and the aspect using GDAL-DEM slope, GDAL-DEM aspect for each slides of computed like images. And that's the computation here. Maybe I can like run it again and show with the htop. Maybe I can.
Maybe
Resides here. Okay.
Okay. Yeah, it's fine.
It's fine. Okay.
Yeah.
So
run.
It's pretty fast in this sense. I run. It's reaching the maximum. In this case, are 3 processor I set up, and then slowing down. It takes like a matter of seconds in this case because the image was like a small image, but it's also like overlapping the time used by each processor. You can see here. I just like setting a landmark mark where some computation are stopped here, and then I try to reassemble the image. So the previous image I created. In this sense, I can like show with another terminal. Chef 3. Okay, well. This is like the sliced, like DRM. Oh, sorry. Like one slope, for example. This one slice of the previous DAM, the slope calculated for a single slice. Maybe I can show the original DAM. Wait, not here. Sorry. I have to.
Yeah, you have
This.
to.
Yeah. Wait. This is like the full DAM. Open a V.
You can also open 2 files.
Okay, I have to open another terminal, right?
No. 2 files, one beyond the other. So if you do the DEM plus the aspect, for example.
Okay.
The original DEM.
Oh, maybe I can open the slope tip. This is like the full DEM when I calculated the slope. This is like the original DEM with the slope calculated. This is what I have.
Okay.
Maybe I can show better with this. For opening another image, how should I do?
Okay, no, it's easier if you do it 2 files, so you did in the same line.
Okay.
And then 2 files, much easier.
Okay, so here I can add the other. Okay.
Yeah, open a tile, the DEM, for example, for aspect.t.
Yeah. maybe
Oh,
4.
slope, yeah.
Yeah, where I go for the slope because
Perfect.
I open this like same slope here. Yeah.
Okay, very good. So, so as you can see, the multi-core operation was first splitting the tiles in four, I mean the full image in four, and then performing a GDAL dam, in this case GDAL dam slope, to
Yeah.
compute the slope for the full, for that particular tiles. Okay, can you go back to the script? One second.
Yeah.
And I want to see how you calculate the width of the image. Up,
Okay.
just
Here
to be
at the
sure.
start, I just grab the
Okay,
full sides here and adjust halved into it.
okay,
Like,
perfect. So you grab the dimension of the matrix.
yeah, from digital
Perfect,
info.
perfect.
Yeah.
You
And I
can,
halved it.
perfect. You can do the same operation also with the lat long. Okay,
Okay.
with using rather than source win, you can proj win, projection
Okay.
win. Okay, so it's really depending which one is easy. The computation is perfect the same.
Okay.
So if you go back to the OpenEV,
Yeah.
okay, um, so there is something that we should be aware when we work in this case.
Yeah, I can
I
show.
talk with the Saverio. Yeah, zoom
Yeah.
in
I will show like the full image, the like the merged image of the four slice
yeah. So
because yeah,
meantime that Saverio is opening. So what is happening when you calculate the slope? You know that the slope is nothing else that is an index calculated
yeah,
in moving windows. Okay, so it's happening this. Okay, because of course in the the tiles on the border are not computed because they are missing the other information
yeah,
because the slope is calculated 3 by 3. Okay, so what do you think is possible, Saverio? I don't want a reply from you,
yeah.
from the others. So what do you think is can be done in another way, this operation? And in case how? Try to think.
Slightly bigger, slight overlap of the tile.
Perfect. So you crop it. So in this case, when you do, for example, the source win, you do the half
Yeah, yeah,
plus 10 pixel. Usually I always put more than, for example, the slope
yeah,
will be enough one, but usually put something bigger,
yeah.
just
Okay,
10. And then you do 10 and 10 from the other side. And then when you merge it, you have to first crop
yeah, crop, yeah,
to this 10 that you added, and then you do the tiling. Okay, so be
okay,
careful about these operations that are more in spatial context, that you always need to do this.
okay,
So in my case, for example, that I work it with the basin in hydrological modeling, the tiling is very tedious because in my case the basin is is not a square, so I
yeah,
can never follow a kind of regular size. Rather, if you would do GDAL calc will be fine because it's working one pixel with the other pixel.
okay,
But whatever is implementing a moving window, you have to be careful about this operation. Okay.
yeah, yeah,
um, so something that you need to be aware is also that when you do the multi-core, be
yeah,
careful because it's very easy that without thinking, you can read from one file, okay, but you
okay,
cannot, you can read from one file with several processors, in this case, one image,
yeah,
okay, but you cannot write back with several processors to one image.
okay,
Okay, so that's why we did the integration later on you did with the GDAL merge.
okay, yeah,
Okay. And also another point concerning GDAL merge.py. Can you show the GDAL merge.py line?
yeah, yeah,
Okay, so that one is a bit old in the sense because there was not a VRT when they built the GDAL merge. So it's much better and fast to use create a VRT and then use GDAL translate.
okay,
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 because that one is much faster, is compressing better, so
okay,
it's more efficient. It's more efficient. Okay,
okay,
build VRT followed by GDAL translate. Okay, so these are
Okay.
the stuff that you have to consider. The multi-core operation you can see by the top, like htop by, but also immediately you can see in the terminal when you're running. Can you go up? When you are running the, yeah, you can see that over there you have 0, 0, and then 10, 10, 20, 20, because these are the percentage of each processor.
Yeah, we are running parallel in this case.
They are running in parallel. So before it was 10%, 20%, 30%, 100, then they were starting another line. Rather, when you work in multi-core processing, you can see immediately that it works. Okay.
Okay.
Pay attention also that this is the so-called embarrassing parallel processing, where you can split, you can split in tiles, and then each tiles is sent to one CPU. They say in this with this terminology. Okay. There is also an internal multi-core processing that you can do it with some flag inside GDAL. Okay.
Okay.
But they're not implementing it everywhere. So in GDAL Warp, I don't think in GDAL Translate they add it. But in GDAL Warp, there is a multi-core option that you can set over there to speed up the computation. Then also in GDAL Calc, in GDAL Warp and also GDAL Translate, you can set the maximum amount of RAM size that you can use it during the computation.
Okay.
It's called cache max something.
Okay.
Cache max, I think GDAL max or mem max or something like this. So if you go back to the htop,
yeah,
from a computational perspective, remember the RAM is 1.
Yeah.
The CPU can be 2, 3, 4, 8. When you are running, so if you have your computer 10 giga, you have availability of 10 giga. If you are running one processor, one process that is already using 8 giga and you have only 10, if you do the multi-core, it's going to be 8 plus 8, 16. So you cannot do it. The RAM of your computer is going to frozen. Okay.
Yeah.
So the default in GDAL is always in PKTOOLS. PKTOOLS a bit, no, it's not really. Is always to use a low amount of RAM. That's why you can do a very intensive multi-core processing, because I don't want to say never fill up the RAM, but it's very rare.
Okay.
Okay. So you can see, so if you run again that cell, you can see that your RAM now is 1.6. So you can see that now is going, this 1.65 should be raising up just a bit.
Yeah. It's over. Yeah.
Maybe it's not, maybe it's so,
it's pretty quick.
It's not able to do tracking. But anyway, you can setting up. Okay. So these are stuff. And if we Google it fast, maybe Anastasia can Google it for us. If you see cache max in GDAL, you can see that is yes, is a flag that you can use it inside, actually inside or even before the GDAL translator to setting up the real amount of pay attention that if that flag, you are going to use it inside the XARG, is going to be multiplied by 2 in this case. You are using 2 CPU. Okay. Yeah. Okay, so is should be something with max. I have it as a default in my operation, and so I'm not checking continuously. Okay, so this is a good example that has been implemented by Saverio by previously watching the recorded version that is on the web. So please, if you didn't do it, please do it, because this is opening the door of the massive data process. Okay. And if somebody is coming to Austria, we are going to intensively use this kind of application in the HPC. So over there, now we are launching 2 processors, but over there we can do 20 processors. So we're really fasting up everything, okay? One point, the Xarg loop, we can consider as a Xarg loop, yes, over there,
Yeah.
is going to ending. So the end of the is where you have a single quotation, space underscore,
Yeah.
is the closing. Can you go down?
Yeah.
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 Before it was up is the opening, and there.
Yeah, that's the opening.
Perfect. And over there and down there.
This for the like time for setting up the time.
Yeah.
This for the for loop. This is like the process, the whole operation, and these are like file referencing for the operations.
Very good.
And this is for the setting up for the number of operations. This is for the number of processor involved. In this case, I put up 2.
Yeah.
And here for the argument. Yeah.
Okay. Okay, very good. And one point, if you want to bring one variable that has been set up outside to Xarg,
Yeah.
so for example, just under bash.
Yeah, I use the export.
Bravo, you have to, yes.
Yeah.
You have to use the export, okay? If not, is not able to read inside. Every time that you enter in a new environment, always set up the export of that variable. Also, because if you do it, you don't use it, nothing happens. So it's not, sometimes I always put as a default and then I don't use it below, you know?
Yeah.
So it's not an issue. Okay.
Okay.
Very good, Saverio. Any question concerning this multi-core? What do you think can be useful? How you think can be implemented? And Anastasia, did you find the flag? Yeah, maybe Anastasia can. Yeah.
Also explain it. So there are 2 ways of
perfect.
setting it. Either outside of a command using like changing the setting, more. I don't know how global it is, but more global way. Using setting it as a variable. We had that on Tuesday as well with using export to export variables into a command, or using a flag with --config gtal cache max.
Okay,
and then the value.
Very good, thank you. So in other words, Saverio, you should put over there before GDAL dem, GDAL dem aspect or slope, yeah.
Or slope, yeah. Okay.
Put before, you put GDAL is in the chat. So if you see the
okay.
GDAL underscore cache max equal.
Okay.
I think the default is in megabyte. No, it is in giga. Can you double
It's
check?
like case. Oh, wait, it's
GDAL,
not ready.
Uppercase.
Yeah.
GDAL underscore cache max.
Yeah.
Equal. I think is a megabyte, the default, equal to 1000. So if you write 1000 there, equal to 1000.
Yeah.
And then equal, yeah, I'm missing the equal, then space, semicolon. Perfect. Okay, so now is going to use it for the GDAL dem that is following a maximum of RAM cache of 1000.
Yeah,
okay.
Just one thing. In what I Googled, it suggests using something like 64. So I'm not sure if it's megabyte.
Okay.
Because 1000 is...
Is giga or no, it's mega, I think, no? I think the default.
I would expect so, but couldn't find it. Wait.
Yeah. Anyway, we can check if it's the default is megabyte or gigabyte. Anyway, if it's megabyte.
Yes, megabytes.
Megabyte. Yeah. So over there, they are going to be 2. So it's going to use maximum of 2000. Okay, 2000. So 2 giga. Okay. So in this way, you can really, even if you have a slow RAM, okay, you can really, probably these images are so small that is not needed use it 1000, okay, 1 giga. So in the multi-core operation, is very good to be able to set in this one. So and then also for people working the HPC, there are some HPC that you work for CPU hours, not for RAM. I mean, they are they charge by CPU hour, not for RAM usage.
Okay.
So what you do, you increase as much as possible the use of RAM, and you reduce the amount of CPU that you're using. Okay.
Okay.
So you need to be also clever in using these resources. Okay. So in a clever way. Or even again, the HPC, you know, if you put a lot of RAM, if you put many CPU need to be free in the same moment. Okay, so in this case, two. But if you put over there 20, you need to have 20 CPU free in the same moment. Okay. Rather, if you put less with more RAM, you have more chance to get inside to the system. Okay. So these are all the tricks that we'll cover for the people coming to Austria.
In this sense, the X-args, like the -P option here stands for 2 processor, but this is like the limit. As soon as 2 processors are free, it starts, or like.
Okay. This is say in few words. Okay.
Okay.
In this case of Xarg, in a simple word, but in the case of the Xarg, they are going to start immediately.
Okay.
You are not in a queuing system and so on.
Okay.
So they are going to start. Actually, even if you put 20 there, they are going to use 3 because you set up 3, and then they are going to wait.
Yeah.
The other 3, okay, and so on. Okay, but this is there is also another one, another Bash implemented multi-core operation that is called new parallel. But in the end, I always use Xarg. For if people knows new parallel, feel free to use that one. Is also newer than Xarg. But in the end, I get used to Xarg. I'm using Xarg. I went a few times to new parallel, but I went back to Xarg. But feel free to explore also new parallel. Okay. Okay. Of course, now we did an implementation in GDAL, but then over there, inside there, you know, inside to these there, they can be anything. They can be even Python script. So it's going to send 2 Python script in the same moment. Okay. Or whatever you put there, bash line, our code, they're going to send it in automatic, in parallel. Okay. So this is really where you do the language integration in a multi-core environment. Okay, so it's very good to have this flexibility. Any curiosity?
There's like something you can set, like a priority of a different task you can put inside there.
No, there is no priority. If one process is finished before,
it starts over. Okay.
It starts over to the second one, in this case the third one, because so the full one is going to be concluded when the last argument, in this case, the them via question mark via, they're going to be processed. Okay. And something that you did very well is that you create VRT. So you didn't create 4 T files of your 4 tiles, but you create just a VRT that is pointed to the previous image. Okay, so that one is really just a pointer. So you are not creating additional data. Okay. The only thing that you are creating is that when you close it, you know, the Xarg, you will have 4 tiles, and then you have to get it back and do it again for assemble it back. So be careful that now you are working with divide by 4 is fine. But if you're working with a full globe and you divide by 32 or by degree, usually I have a table. Will all my globe is divided by 1 degree, 0.5 degree, 0.25. In this way, I have already my X and Y coordinate of each single tile. So I'm going to read from that tile system. Okay, so unfortunately, we are moving in a multi-core environment. GDAL and GRASS2, there is a lot of work need to be done for the multi-core implementation without the user manual editing, let's say, because now you are putting divide by 4, blah, blah. So I am doing divide by 64, you know, to divide in. So the ideal will be that this kind of computation will be done in the background without user interface, because you lose a lot of time, you know, in thinking, understand, divide by, you know. So they are moving slowly because, you know, open source, nobody paid the people, so they need to have a bit of free time to develop the tools. But it's the way where the geocomputation is going, okay, for this aspect. Okay. Anybody else was doing a bit of multi-core in other environment, pro and cons that you want to share in other language?
I just wonder if this is the only way to do the multi-core computation. Like I do it for my Python script, but yeah, it is automatically using like multi-core. I don't know how to set it up anyway in my computer, but I just wonder if this is the only way to change the settings.
I mean, in the Bash GDAL environment, yes. So this is the only way to do it. Then, of course, you can do, you know, you can see, we will see also with Rasterio and with PyGeo that you can use the multiprocess that you are using in Python also inside Python. Okay.
Okay. Yeah.
Okay. So because there are libraries that are reading the image, so it's just a matter of if you are outside Python or you are already inside Python. So if you are already inside Python, use the multiprocess of Python. But if you are still inside, you know, and then also when you work in a HPC, one node has 10 CPU, another node has 10 CPU. So you can work with one file for one node, another file for another node. So having one file for the 20 node then is more complex. You have to do with the OpenMPI and it's getting a bit complex. So it's good to know this alternative way to be able also to use the cluster intensively, okay? So I don't want to say that this is better than the other, but it's good to know the alternative to pick up the best when it's needed, okay? Yeah.
Okay, thanks.
Okay, very cool. Okay. Any other multi-core feeling? Okay, if not, we can start the class. So you can release.
Yeah. Sure.
Okay. Okay. Let's go here. So before to start the real class, I want to have from you guys a little feedback that I prepare concerning the speed of the class, let's say, in terms of, you know, concept of using tools, if we are going too fast, too slow, and so on. So if you go to this web page that I will write inside to the chat, this one, you can click in. So now is the chat. You can vote and we can see the result immediately. And in this way, I can understand how, yeah, the performance, if we are going good or not, and so on. So vote, and as soon as we vote, I think you should be able to. No, but wait, we should not see. Meantime that you vote. Okay. Okay. You vote yes?
Asking for an account to register with this parenting?
There is also a skip, so you can skip it.
Okay.
Yeah, yeah.
Okay.
You can do skip.
Sorry, I'm working on 2 different machines.
Yeah.
Anyway, Giuseppe, we see your screen right now. I don't know. Yeah.
Yeah,
okay.
but it's, I don't want to show the.
Yeah, no, that's why. I mean, I guess it's
to see if we are going too fast to have independent. Yeah, you can see all my code over here. Okay, vote. I think we can go back. Yeah. Okay, let's see the result. Okay, we are more or less right in the middle. People are still voting. So I will try to so for people that we are going too slow, I would suggest that try to get the best from the lecture, and also look in the manual in the same in the same task or concept that we are teaching tools and so on. This way you can fill it up the time that that we are teaching, and feel free to jump with one question to leave it up. I mean, to bring up your expectation, and then come back to the pace. And for people that I'm going too fast, so people in the middle, so we are fine. People that we feel too fast, is a matter of putting a bit more hours. Okay, so these tools need a lot of hours, and I mentioned in my email that you need at least 20 hours per week to get familiar, including the lecture, to get familiar with the tools. Okay, so and then also in 2 weeks we are going to have 1 week that we call a catch-up session, where people can just have time to catch up with these. Okay, but it's important that you put hours, and again, try to use it as much as possible, the tools with your data. Okay, these are very important to get familiar with the data, like for example Saverio was doing. Okay, was doing just because if you just follow the lecture and just you click the Jupyter, everything is going to work. From when you use your data, then over there is where you see the difference. Okay. Perfect. So let me go back to the lecture with the virtual machine. Perfect. So let's we are in this. Okay. So I need to cover also the GSIM explanation. The GSIM. Several of you already send me the explanation of the AWK GSIM dataset. So if you go into the syllabus in the lecture of 2 days ago, 3 days ago, Tuesday 9, so you can see that I had over here the solution. And we have 3 main solutions, okay, that we can see together. Some, especially the first 2, you guys have done something very similar, okay? I don't want to say pretty the same, but similar, and with the pro and cons of each one. Okay, so let's see what they are. So I will open. So if you go directly, you can copy this script. If you copy this line in the terminal, you can go directly. You can copy directly. Okay, say overwrite. You can say yes, actually, and then you can open the file. Manipulate. And to open a bash file, okay, the best way is to open with the Emacs or with the Emacs or with VI, okay? I prefer Emacs, but feel free also to use VI if already used. If you put the end over here, your terminal is going to remain available for you. And now you will see. You enter. So Emacs is working this way. You have an editor here. This window you can read, and then you can do never show it again. It's going dismiss startup screen, and then you can have you can have the full so this is nothing that's a text file. So we can work in this directory, and we can see the different monthly. Yes, we are in this directory. We can see the three different solutions. So as you can see, we are using only only the United States files. So we are not using the full data set. So, but with the last one solution, feel free to use the full data set, because you will see how fast it is. Okay. So you will remember that we were going to create an output that was going to be over here, where you have the state ID for one particular month of 1 year. You're going to have United States, sorry, the ID of the gauging station, the lat long, and the value of the mean of the discharge in this case. Okay, so you will have one file, okay, one, yes, for this one. Okay, so first of all, so this is the first thing that you have to think about. Are going to be more the file, or they are going to be more the date that we want to running over, okay? So if you do the math, probably United States, they are few than dates. I don't know, I didn't count it. But if you think in the in processing the full globe, these are 32,000 stations. Okay, so it's better to create, you know, a date file where we are going to loop in later on. Okay, so with AWK, and I can copy one line by one line over here. Okay, let me create this, make it this way. Yeah, that's okay. We are going to, I remove some file just in case I have it. It should be not there. Okay. Perfect. So now in this case, I'm going to get only the United States file, and I'm going to create a file that is going to be just my dates. Okay. So it's quite fast. You can go and open this file and see that there are head. Okay. Yeah, I have just collecting the dates. Okay. So now at this point, I can go for each file again, but look, I'm not looping through the files. I'm using the power of bash by looping, by consider this one as a huge, big file, okay? And I can get the GSIM station. So now if you do GSIM station, this one, I can show you, you can see that I'm getting just the ID of the station. Okay, in this particular case, I'm going to get just this one, nothing else over here. Okay, print that actually the number 4, so just this one, nothing else than this. I can do the same for the longitude. Okay, and I will have another file now, only longitude, and so on for the latitude. Now I will have three files, one producing the 3 columns, one produced by the GSIM number, one produced by longitude, one produced by this. Okay, if I run this one, yes, with the paste, I'm going to process the 3 column and then paste as this one, 3 column, and then, sorry, 3 column like this, and then paste in this way. So now the output is going to be 3 columns, okay? Now I can use this one to go and looping through the files, okay? So pay attention about this, that so over here, there can be a potential mistake. Can anyone tell me? In this line. So I need to be sure that this is not, because I'm doing this, I'm doing 3 lines, 1, 2, and 3. And then, okay, 3 lines like this, only 2 columns, and then I do this.
Like we should be sure maybe each latitude and longitude is for a specific station ID, or the
Yes,
correct one, I mean.
yes. So what does mean that if over here one is missing, let's suppose that in one station there is no longitude for any reason, it's going to be missing this one. So this is going to be like this, and then is going to be attached in this way, okay? And not anymore like this. So always double check. So you should count first the longitude, second, also the latitude, also GSAM, and then if there are same number, could be that are correct, could be, because can be that also is missing one latitude, one longitude, the one gauge station in different file, and then it's going to be this shifting, okay? So always pay attention to what potential can happen if there is this problem.
I have question here.
Yeah, please.
Yes, I have done the similar things, but I just first count the latitude, longitude, and the GCM. All these are the same. So after that, we need to sort out this, like you put a sort out, because I have not done it.
Okay, the sorting over here is just for having a in sorting based on the ID, in nothing else, okay? So the counting is more if something is missing. I know that nothing is missing now, okay? So we can do it, but it's something that you have to do in advance to be sure that is that there is not this kind of situation. Over here, the sorting is not preventing that kind of error. That one is just sorting to have in order, you know, just to have in order. That's it. Actually, even sorted, yeah. 2, 3, yeah, it's numerical sort. Okay, so it's not for preventing this. So now we are going to, you know, looping through using the dates, the column of the dates, the one before, we are going to, yeah, this one, we are going to loop through this one. And as you can see, let's count how many there are. Okay, so there are 1,300, probably the United States, probably, you know, how we can count how many there are. How many file of United States? I want to know how many file. LS, then anyone?
And you type WC.
WC count, okay, WC. Okay, so they are, maybe because, okay, because I put less, maybe. I put only few of them, actually. I put only few of them for the example, okay? But in total of United States, then 9,000. So it's much better to looping through these and not through the files. So many of you were immediately thinking, can I loop through the files? But in this case, what will be better to loop through the dates, okay? So, and this is what I'm doing. I'm looping through the dates, and I collect the information of the mean, and then I join with a join operation to these three output. In other words, I join by this one and adding the mean over here. How? By joining based on the ID. Sorry, yes, in gauging station ID. Okay, so this operation is the one that potential can be a bit slowly, okay, because it's a looping procedure. Remove. Okay, so this is just removing. Because it's okay, there is, okay, sorry, there is this for the virtual machine. There is one option that is protecting, is a default option that every time if you do remove, you have to do -Y to say, do you want to remove it? Yes. So now if you go back to the loop, and you put the remove over here dash y is going to done. I think you need. Okay. Maybe valid option. Maybe it's a copy now. Edit, copy. Okay. Remove is not the Y. I think it's F.
F. Yes.
F. Yeah. Thank you. Paste. Okay. So now it's processing each single date. Okay, until the end. So this one was one example, and we can see later on as soon as finished the result. So did you get this example? So it's very similar to some of you, but slightly different. Okay. So we can go to the next one, where in this case we were looping through the file. So we were doing file by file. And this one was quite, you know, you get 3 variables, one for GSIM, one for lat long, and then you were save it as a variable, import it inside AWK, and then inside AWK get only the mean column, okay, where the mean column is not equal to NA. Okay, so also because there are some mean column that is equal to NA. So in this case, it was going to update over here. Okay, so as you can see, this one is a for loop, and also most of you have done something very similar to this one by looping through the file. Is the most easy thinking that somebody is doing. I was also doing in this way. And then through the years, I learned the last solution, where this is the beauty of AWK. So you can consider, let's see this one. You can, and this is the fastest one. So you can consider the full files as a unique file, okay? So now you can consider 20 files, just merging all together, become one file altogether. So at this point, you can go looping through the file, not looping, you can go through this big file and select with some if condition, whatever you need. Okay, so there are, in the beginning, there are some gsub to change the comma to space, or to remove this value, this one, okay? Then you do gsim, and you do, if $2 is equal to gsim, then print the for one, like the one that we did in the top. Then if it's $2 is equal to latitude, bring the value of latitude. And as you can see, every time I'm creating a variable. Okay, then is doing another if condition, going down to the file with a matching. So it's not equal to, like we did over here, but where the format of the line is equal to this one. So in other words, let me stop this one. So in other words, if I get one single file, ls us 009, yes. So if I get one single file, 360, okay, I can see that my mean, in particular, my second value, so in this case is NA, and we will see this anyway, is this one. Sorry, my $1, my dates. So I'm getting the dates, okay, over here. And has to matching this pattern that is the four number, 4 digit. Yeah, the first 4 digit is a number. So in this case, from 0 to 9, from 0 to 9. So I can identify the format of this one. Okay. and is not equal, and the column number 2 is not equal to NI, like in this case, then do an action, okay? And this action is this one. You need to print the station, so this one, lat long and $2. Okay, now the magic is happening. Over here, I'm going to split this file, this huge file that I was processing, this one, in several files, okay, where having as an ID of the name, you know, the $1. So in other words, this, okay, the substring of this one. Okay, from 1 to 7. So from 1 to 7, I'm going to get this one. And this operation is going to do the splitting of each if condition in his own file, and done, magic. Okay, so as you can see, a very complex for loop that was keep running. Now, if we try to use it, it's going to be really fast. Okay, so we can do it. Where is going to save it? Okay, output, perfect. Yeah, copy, edit, paste to the clipboard. Yes. Okay, so now too many opening file. Yeah, could be that there is some issues with too many files, but should be possible. Let me put maybe an asterisk over here, 1. Anyone get the same problem?
Yeah, I had that as well, also with our solution.
Sorry?
I had the same problem also with my own solution.
Strange, last year was working. How do I TXT? Okay, okay, we probably there is some limitation that we need to check. It could be also the RAM, because before to writing is going to be saved to the RAM. Okay, so could be also something in this context. 0. So if you remove it, okay, but if you don't remove it, it's really yeah, it's not really. Yeah, if you look, if you have less, then it's working. Okay, so probably there is some limitation in the number of files. Okay, so now this one has been created. Okay, but anyway, here is because we are working in the virtual machine. Okay, so now we have one file. So, okay, this one is really 2020. Okay, so let me see if this one, maybe I'm processing only one file, I don't. Anyway, if you work in directly, so people with native Linux can try in his Linux and should work. Yeah, probably here I'm processing only one file. That's why I was working. Okay. Anyway, it's clear the concept. Okay, so this is the magic of splitting. Okay, so I was suggesting also to some of you to looking in a web page for this one, and some of you came very close, but you can see that sometimes very complex, even long script can become really short and elegant when you know what to do. Okay, so it's a matter of trial, but this splitting operation is very important, because then each one of these file, okay, each one of these file can go to a different CPU or imported in Python for some additional analysis. Okay, so it's a good way of trial. Curiosity on the
I have a question.
Yes, please, Julia.
In this first solution, so you are printing only if all the 4 if are solved.
In the first solution, this
No,
one?
in the third, the last one.
In the third one?
Because there are 4 if,
Yeah.
and the last one is also an end condition. So in this case, there is no end in between the 2 if, but the
Yeah,
print
because
is
okay, because these one are done in any case for each line. Okay, each single this one is done for each line is done this one, and then is done. But when it's arriving to this, need to be done this condition, that is the one that is referring to
we lost your voice for a few seconds.
yeah, one moment. Okay, cut. Yeah. Okay. Okay, so this one is responsible to select this line and only and NA is $2 is not equal to NA. So in other words, it's going to select only when it's like this with a number. Okay, and this is going to be independently from this one. So each one of these, because there is the semicolon, is repeated in each single line. That's why I'm setting a variable, and then later on I carry over in the print action. Okay. Okay, good observation. Yeah, thanks for pointing.
I've got a curiosity question regarding the third solution. So shouldn't Linux produce a swap file for the of the memory, because so if it runs out of memory in the third solution of creating all those files, shouldn't it produce a swap file?
I don't think
additional RAM.
So I don't think is a matter of RAM. Before I say RAM, but I don't think it's a memory, is a RAM problem, because every time that is finding something is going to be append to the new file. Okay, so and the fact that it was going to the swap should be done automatically inside Linux. But we will Google it, this problem, because it was not happening in my machine, but could be that there is something RAM related, swap and so on. Okay, but also sometimes can be too many files, because there are some system that is not only file size, but it's also how many files. So could be that the virtual machine has some limitation in how many files is opening, okay? Because indeed, this one is opening, 1,000, we say the dates. So these are the dates. So there were 1,000 dates. Okay, so could be that there is some problem over there. We will come back and see this error. But test it in your, if you have a native Linux, test it, okay?
I've got the same problem.
Ah, yeah? Okay. It was not happening last year. Anyway, and on my machine also this year I try. Anyway, I will try to. Sorry?
I got the same error as well, so I think, yeah.
Okay, we will figure out why in the virtual machine is not working. Okay, but anyway, this is a good way to splitting, in this clever way. Okay. Any other question in this regards? And yeah, so all the solutions are here. Feel free to copy paste and checking and understanding better. Okay, so before let's have a break before to starting the PKTOOLS. We come back at 30. Okay, in this way we have a bit of restoring time. Okay, let's move to the second part of the where it is. This one. Second part of the lecture, and in particular, yes, okay, and in particular this one for the PK tools. Okay, so this one over here. No. PK tools. Yeah. So I had the honor to working for several years with the Peter Kempners. Last year he was also teaching some classes. This year cannot be. He was not able to teach in our class, but he's coming to Austria for a following up on the PK tools and PyGeo tools. In particular, the PK tools and later on PK tools are the implementation in C. Call it directly under the bash environment as a GDAL. And later on in the last 5-6 years has been bringing these PK tools inside the Python and creating Python binding and use it the so-called and creating the so-called PyGeo library. So the PyGeo library has been, there are some example over here down in the PK tools over here, PyGeo, but they are referring to the last year. So if you are going there, you can see lecture, but they are referring to the OSGeo 15. So the installation can be a bit tricky, but we are working on having something ready for you guys in case you want to use it. Going to the, let's say, to the backbone of PK tools, Peter has been developing these tools for 25 years. We were together in 20 years. Yeah, we were together in 2006, but he was already doing his PhD and developing these tools. And they were starting together or just after a few years with GDAL. So GDAL was raising up, and PK tools also, Peter was already developing his tools. So these tools, they can have an overlap in most of the case, but sometimes, quite often, the PK tools are really quite unique, okay? So then around 7-8 years ago, thanks to Francesco, he was creating the binding to install it, PK tools, directly under the apt install. So if you do apt install PK tools, is going to install it. It's something that has been installed in the beginning when you install the virtual machine in the background, let's say. So now you can call all the PK tools directly in the command line. If you do PK and then you press the tab, you can see all the PK tools that are over here, okay? Be careful that some of them, they start with PK. They are not PK tools, they are system, like I think this one is not a PK tools. Yeah, package, so console, so it's something else, but most of them are the one that are related to PK tools. So if you click over here, okay, you can see a huge, very well documented page. And in particular, if you go to available tools, you can see all the different commands that are perfectly the same that are listed here. Be careful that there are some that are not installed, like this one I mentioned the other day, because you need a special procedure to install the PK last two image for LiDAR image. Anyway, something that we can figure out together if you need. Some of them are really, you can immediately understanding. So for example, PK crop, okay? And you can see immediately over here that you have the typical bash syntax where you have you know, the command, then everything that is between square brackets are optional. And then you have always input and output identified with -I and -O, input and output, and everything else is between brackets. So pkcrop can do whatever GDAL translate can do it, nothing more. The advantage that, for example, there was the advantage a few years ago was not installed the cut line, so using an external vector file or raster file to crop it to the same dimension, and he was using. I didn't use so much pkcrop due to the fact that, you know, it was already using GDAL. So if you see something that is already done in GDAL, use GDAL. Don't look for an additional. But sometimes you can really setting something particular with PKTools, even if they seems very similar. So as you can see, the syntax, for example, the syntax and the binding, sorry, the labeling that is using are perfect the same like the like Bash, sorry, like GDAL. Even the compression algorithm that we are going to see, they are perfect implementing the same way. So most of the you know, upper left, the terminology, upper left X, low left, and so on, you can use the same. You can do it a bit more than GDAL in terms of processing. So you can do very fancy PK filtering. For example, you can do moving window filtering. You can do it moving window, moving from one pixel. You can do in a kind of block. So you can do in the temporal dimension. So it's really fancy stuff. You can do it with these tools. And you can creating from you know, you can do it even a bit more than processing, like really image processing, like, for example, some classification, and you have classification for, you know, not supervised classification. So when you have training data set that you can implement it, okay? But for these, for the, you know, for the fancy stuff, PKTools is very good for the pre-processing. But for the fancy stuff, I would say enter in Python with the image already standardized, and then over there with the use of PyJ, you can even combine it with the sklearn and with the Antonio teaching to have a full image, let's say, image processing capability. So it's really good for this. Something that we will see in particular, the pkstat. Sometimes we already saw some application where you can check the statistical of the statistic of the image, and they are much better. And you can see that are you can print in the terminals, and then you can manipulate with AWK, with Bash in general. Yeah. Okay, so yeah, something more also important that sometimes can be a bit hard to understand, especially with the command, but again with the help. But he has been used it perfect the same terminal of GDAL, so you will find a reference and you can go back to GDAL if something is not clear. Over here there are quite plenty of the example nowadays. There are quite a lot, so you can see different example and sometimes even combine it, you know, with a bash command for doing some application. Okay. There is something particular, the use of, or quite often in all KEYS tools, there is always the possibility to use an ancillary data to do a masking procedure. So, and even to setting some particular no data, okay? So there is always this capability to, okay, doing the operation, but in the meantime, don't do it under this area, put me no data in this area. So this kind of or capability is always present. So let's jumping into the class, into the example over here that we oops, this one that we can follow along. So if you open this page, okay, you can arrive to this one, and then you can open the terminal with the Jupyter Lab in the exercise PKTOOLS. Okay. Mm-hmm. Okay, so over here you can see the Jupyter Lab opening. I will have also the terminal. So I'm going to referring also to some example that we did in the previous class in order to bring you back to your attention to GDAL and how we did it in particular last time, but also to remind you that some operation that I say these are good to know but are not efficient, is good to repeat it, to understanding why they were not efficient. So for example, we were creating a mask. If you remember this operation, we were creating a mask using transforming first to text file, then using AWK, having all the pixel value between 2 and 4 setting as a 50. And we were creating just a mask. We were changing the pixel value based on some condition, okay? So this operation was possible, but I say, and you can see that is quite long. But in other words, what I was obtaining these geodata. See okay. So as you can see, OpenEV, we were creating this data that was the value of 50 was replaced in this condition between 2 and 4, okay? So all these pixels become 50. So now we want to see, can we do the same operation with PKTOOLS, but without going into the text file and do it directly with the so these can be done in a clever way using PKTOOLS. And in particular, we will see the flexibility of these tools. In other words, I'm going to change the value, and I can change the threshold between the value and also the final output. So in this case, for example, I'm going to use get mask. So I'm going to create a mask, a masking value. I use the compression perfect the same like PKTOOLS, and I'm going to say between 1 and 2 in the image, where the condition is true, put 1. Where is not true, put 0. Okay, so as you can see, I'm creating a binary image. So this condition, and once again, I can setting the output type to byte because my input are 0 and 1. So I don't need floating point, sorry, my output. My output in the final image are 1 and 0. So I don't need floating point, float 32 or even integer 32. I don't need it, all this information. I can use it, the byte. And as you can see, it's very small. But I can also do it some other, I can also do it other values. So these values are not predefined. I can change as I want. So it's not an issue. And I can even, invert it where is 0 and 1. I can do even the opposite, okay, in the output file. So this is giving you all the flexibility that you want in setting up, in getting the mask. Be careful, because we will let get the mask and then set, that means apply the mask, okay? So this is quite doable, easy to understand the threshold, and we can have 3 different maps. So if we run this one, okay, so you can see it's very fast. I even create 3 output, and it was much faster than this one, okay? So now I will have my 3 map that were going to be, is the crop? No, without crop. They're going to be 3. Let me see, this one. 11, 0, 1. Okay. So now I'm going to have my 3 maps that are completely independent. And each one of them, once again, be careful, because now you have the 3 maps you don't see because they are just 2 values. So you need to stretch it to see them. So as you can see here, it's 0 and 1, but then this other, is another, is not 0 and 1, but it was, 0, 0 and 1 over here, the opposite. So the different combination that I was creating, okay? So this one was 50, or another one 1 and 0 also in this case, okay? So as you can see, I was play with this number to get play with this number. I was always created 0, 1, but also here you can put any number, okay? Over here you can put any number. So I was putting 1 just to use it as a mask. So now what I can do it, I can use these masks that are independent to setting, and I can use it more than 1. So the beauty of this, I can use more than 1, okay? So for example, I can setting and say, okay, where my mask is 1, put -9. Where when my second mask is 1, put -5. When my mask is 1, put -10. So for example, I'm going to making an analysis of an image, and I'm creating a mask for the cloud and a mask for the water body, okay? I don't want to create both of them and mask that then I cannot retrieve it. So I can use it to negative value, or even in this case, if I have a third condition, in order to see that I know all my negative value are value that they are not interesting to me. So at this point, I can setting to my input, okay? I can set into my input these 3 negative value, okay? Be careful that also in my case, my data type need to be accept the no data, because if it's byte, cannot be negative, okay? So always think about the data type, okay? So you will get several errors in the data type. I'm already tell you. So every time that there is something weird, check the data type. So now if you run, okay, as you can see, extremely fast, you don't need even the time to think. And we can see now, okay, so if I get now my 0, 1 underscore mask, usually always put MSK that has been masked. Yeah, should be this. Okay, now what I have? I have my image that in the different where I created different condition, I have the value. So for example, over here, you can see minus 10. Then somewhere else, okay, minus 10, and then there is this gray area, probably is the, you know, this is the minus 9, and so on. So I can say, okay, whatever is negative, don't do some operation. Okay, so that's why it's important, and this is extremely important when anyone was working, for example, actually, yes, because you asked me, with the quality flag, quality control flag of MODIS of Landsat. Okay, so usually they have an additional band that report the quality values, say the quality of each single pixel. So you can use this value in the band to use it and to mask out your bands below, let's say, okay? So there are extremely important. Now I use it another file, but can be even the same file referring to another band, okay? So these are very complex way but you know, without building up your own. Probably to do this in Python, you need several lines, okay? So overkey is really straightforward to do this kind of implementation. Anyone was using, yes, Lucy, Laura. No, who was Lucy? Sorry.
It was me, sorry. I had a question about the no data values, because I'm looking at the output and you can see the different, you know, -9, -5, -10 in different places. Does that mean there are 3 different no data values associated with this?
Good question. No.
Okay.
And we can check it which one is carryover. The no data is, in particular, is over here, the no data is what I'm going to put in my image to consider it by myself as no data. Okay, be careful. Okay, so
yeah, okay.
Okay, so indeed, if I go over here, look, there is neither the no data labeling. Okay, so it's just my consideration of no data. Okay, and always remember the no data as a value. Okay, so over here now is not labeled, and actually we can even go and check the labeling, the no data labeling. Probably there is nothing. Yeah, actually, is this one is probably or the first, but in my case, only one is labeled as a no data, but I consider all of them not important, let's say. If we want to call it no data, we say not important, okay? But be careful about, because now if you do some operation with the GDAL, it's going to consider only one of these, not this one. So if you do a sum or whatever, you do maybe even how you call it, a resampling. A resampling, the no data is going to consider this. So GDAL is missing flexibility. Rather, PKTOOLS, you can have a lot of these. And actually, we can say that in PK filter, you can say, okay, all my negative do not consider. Okay, so there is a slight difference, but it is good to point. Thanks for pointing. So anyone was struggling in this kind of operation with PK composite. So, and actually, Lucy, you were asking me the other time if GDAL translate can crop, based on a shapefile, and then I say yes, because it's getting the extent, but cannot do it, the masking operation, if you have just one, you have a shapefile, a triangular, GDAL can cut as a rectangular, but he cannot remove it over here. Rather, with PK set mask, you can do it. You can get the shapefile, you can change to raster, and then you say burning value inside to the shapefile 1, outside 0, and then use that 0 to mask with the PK set mask, okay? Okay, so always remember the difference between get mask means create the mask, And then setting means setting, apply the mask to other image. Okay, so you are going to use it a lot, this kind of stuff for creating your flow data. And we are going to see some application also, you know, in more complex environment, you know, like for example, when you want to create a composite. So the other day we were saying about GDAL VRT that was, you know, creating an overlapping of image. So if you have two images that are in overlapping, you can define what is going to do in the area, you know, where they are overlapping. It's just getting the, I don't remember if the last one or the first one in the list, okay? So you can check it. With the PK composite, you can decide what is going to happen between the two areas that is overlapping. So in this case, for example, we can calculate the mean and the standard deviation between several images, the typical, for example, Landsat or MODIS composite, okay? And how? But we can even say, okay, do the overlapping, but without, you know, without considering all the pixels that are under a mask file that I previously created, or that is my quality control band, for example. So if I run the first line, I can create my, you know, my mask. So I can even open my mask. Okay. I can open this mask. Let me make it smaller, this guy. Okay, so my mask now is the month 1. So I'm going to check all my geodata, the ls geodata. I'm working this folder, LST, where I have, you know, I have several files. Okay, all of them are, you know, are file under the same system. Okay, so all of them, they are LST, land surface temperature, for different modes. Okay, so I have over here, I have several files under different modes. So I can open all of them. Okay, and I can see that they are perfectly in the same situation. So I want to create one file for making the mask and then apply to these masks during my composite. So this is the concept that I'm trying to show you guys. So now I'm going to create my mask based on this condition, and I'm going to get my file that is the mask1, month mask1 MS. So now I have this file that tell me, again, be careful that sometimes you don't see that over here is 0 and over here is 1. So now I'm going to use this file as a masking procedure to get the mean in all these value below here, but not here. Okay, and how I'm going to do it. So this one, remember that this one is number 1. Okay, so I'm going to say, okay, do it the mean. So you can see, and we will see now this one, do it the mean, conditional mean. Where is the masking is equal to 0, don't do anything. So do it only where there was 1, and putting 0 in the destination value under the masking condition. Okay, so be careful about this, that there is a for loop inside a inside a full line of bash. And if you do this one, just this, you can see that this line is nothing else that, you know, printing the input that I want to use it. So this is going to use it all the input file. Okay. So now if I running is going to apply first the mean and then another line, the standard deviation is perfect the same. Okay. So, but again, and this operation, so it's getting the mean with all this file, but not doing the mean under this condition. Okay. And if you see the PK composite help is very huge. Okay. Help, you can access to the same page, to the same. Is very huge. So really, you know, you can use the mask no data like we are doing. You can even specify the band of that particular file to use as a mask. That's why the quality control band, for example. You can crop in the meantime. You can use the destination, the source no data, and the band no data. So it is really complex. And be careful, for example, over here, input image files. That's why we were using 12 and not only one, okay? Because there is the S that you can say more than one file. So these are really, really important for this kind of temporal aggregation in the band dimension. But if you consider day of the year, each single band 1 day is the same condition. There is something very fancy that you can even do it. It was over here. You can even do it temporal. Yeah, wait, you can do even weight, you know, you can say, okay, band 1, 10%, band 3, 20%. So you can do a weighted average between the band. So it's really complex, the stuff that you can do it in these regards, okay? So always check back to the example. And I have to say that quite often you have to try and then do it a bit of back engineering to reverse engineering to understand if for what you did is correct or not, because you will get, if you get an output and it's not a syntax error, then you have to really see is correct. So it take a while to enter in the thinking of Peter, but when you did it, then you can fly with these tools. Okay. Something similar is PK stat profile. Okay. PK stat profile is slightly different than PK composite because PK composite can solve this situation. So when the two images, they are in overlapping, but they are in different extent. Okay. So it's doing this kind of situation over here. Rather, PK stat profile is doing when they are in perfect overlapping. Okay, so it's not checking all projection, pixel resolution, and all this stuff. So the image need to be, it's like GDAL calc, but you can do some predefined statistic like mean, standard deviation, minimum, maximum, quantile, this kind of stuff. So it's pretty the same. How you do it? You create a VRT with a separate option. So your VRT that is piling up all together like this. And then you run the PK stat profile. So be careful when you run this, because you can compute, and this is also the beauty of this, two statistics, the mean and the standard deviation, and you will have an output with two bands. Okay, so for example, this one, as you can see, has been running, okay, build VRT for this, PK stat profile, you can see is using also the same computational process labeling. And over here, if you see now, the standard deviation, actually something very important is also this one. If you do, I didn't show you, ls-t is going to sort it based on the on the time. If you do -tr, it's going to sort based on the last file. So the last file that has been created is this one. So I can immediately put here, Control A, I go back, open EV, and I check it. Okay, so now, open EV, open EV. So now you can see that this file has two bands. So if you do double click, right click, rasters, and you have two bands in this file. So one is the standard deviation and one is the zero. Sorry, one is the mean. Okay. So so always so yeah, the beauty is PK profile is faster because it's not checking all the overlapping, so give something by default. But again, also if you enter in the this one is a bit shorter. PK stat profile is much shorter than PK stat profile. It's much shorter than PK composite, but is more efficient when your image, they are all the same, okay? Also, for example, over here, you can consider the no data, okay? So no data, and is going to be the no data that is used inside the calculation. No data value. Actually, also here you can put more than one, okay? Something that is not really obvious in GDAL directly, okay? So these are, I didn't stop because they are very similar, so I want to show you all together. So now the words to you. They say, cool, I can do all this aggregation that was taking me age to do it. Now I can do it in one, just few lines, isn't it? Anyone want to sharing some thinking? Yes, Laura. No, Julia, sorry again, because is happening, the hand
No.
is coming to
No,
Laura's
no,
face.
no,
And
no problem. No, I was wondering if the output is always a TIFF file in this case.
okay, so the default is always a TIFF for GDAL and PKTools, but of course you can define with the -OF output format, you can define.
Okay, but
whatever there can be always in the Rust environment, of course.
and is there also the possibility to do something like the virtual raster?
Sorry, to?
Is there also the possibility to create a virtual raster also in this case, or it's better to do it with GDAL?
Okay, so the virtual raster, you can use it also GDAL translate as an output, can create a virtual raster, okay?
Mm.
So with PKTools, could be, not always, okay? So you need to test. Okay, so quite often with PKTools, I just get an output. Of course, if you say I do it something intermediate that is light, and then, but not always you can do it a virtual raster with PKTools. But even with the GDAL, sometimes you can't. It's going to complain if you put it. I'm not sure. I'm not sure. Because I always did it when I know that can be done.
Okay.
So sometimes I don't know if it's complaint. A good question that you can try. Okay, so over here you have in PK composite, or even in the stat profile, you have yeah, the output format. So also here you can see no, probably you cannot see the formats over here, but they are the same that is in GDAL. Okay, so I can even try. Output format VRT. I don't know. This one I never tried. Look, is doing, but I don't know if it's going to be. Yeah, it's not going. Yeah, you see, you don't get it in this case. I think most of the tools in PKTools, there is always an output TIFF, okay? But most of the time he can read VRT, okay?
Sì, okay.
Yeah, yeah. Raster band is not supported, yeah. Okay, good point. Any observation? Who is working with Landsat and MODIS? I say MODIS and Landsat because these tools are really good for when you use band combination, yeah, mosaicing of the image. Anyone?
Yeah, a bit on Sentinel.
Sentinel, yeah, also Sentinel, they have the quality control, or at least the band, you know, the mask, how you call it? Yeah, the mask band. Landsat was the old AK. Now I don't remember. In Sentinel, I didn't use so much, but it's something that you can testing this composite. Okay. Anyone else thinking about how we can use it? How I get so many? How we can use it? So anyone say, I was trying to do this, and it was taking me age. No? If okay. What do you think, Saverio? Is something that you can use it?
Yeah, there's like a lot of use for this
Okay.
as a fast way to like thresholding things and like
Yeah.
label them like no data or as yeah.
Perfect. So it's a lot of trial. So in the beginning,
Yeah.
you will get a bit of frustration because you need to understand how it works and reading the manual, and sometimes doing a bit of reverse engineering to understand what you
Yeah.
did correctly or not. But they are very powerful. Okay.
Yeah.
Okay, so let's do a bit of filtering. This is something, another operation that, you know, downscaling, upscaling, or filtering, moving window, block window, and all this kind, wavelet windows filtering. So all this kind of aggregation, disaggregation, you can do it with the PK filter. Of course, you can compress, you know, you can set the dimension of your windows, okay? The dimension of your windows, and you can set so in this case, 10 by 10, and this one is going to be block window. Every 10 is going to move and do the average another 10. So in other words, an average of 100 pixels. So I'm aggregating from the typical 90 meter to 1 kilometer. So making 10 times bigger, okay? So bigger, yeah, the mean, and among the pixel, I want to do the mean, okay? And I do it this way. If I don't put this, okay, it's going to do the same, be careful. But if I don't put this one, it's going to be the typical moving window where the pixel size doesn't change. So it's going, and actually it's always better to, yeah, actually is in this line over here. It's always better to do it, you know, in a not even odd value. In this way, the center of 1 pixel, the 1 pixel is getting the mean of the 11, okay, 5 plus 5 and 1 in the center, file around it, okay? So, and in this case, I can even do it a circular moving window. So you can see if I run this one, for example, the two images I'm getting, one is going to be more blocky, so aggregated 10 mean, and the other one, so I do the same now. I enter here, I do the RT in this way, I get it immediately without typing. No, sorry, maybe that's too fast. Mean, yeah, perfect. So now this one, I can get this, so and I can get also the other one, but the circular 11. Circular. So now the two image, they will be slightly different because I did two different, you know, windows filtering. So you can see that one is more blocky because I multiply by 10 each thing. No, multiply, yeah, I multiply the pixel resolution and getting them in. Rather, the other one, I still maintain the same resolution, but it's going to be smoothed in a, this is the typical when they say kernel filter, that is a circular kernel filter, okay? So you can do different kind of filtering. Let me see, probably, and you can see, and actually, if you do it, if you also over here, you go into the help file, you put dz, is going to do it, you know, if you have 10 bands, is going to be the dz, the z is the third dimension, the band. So in other words, you can create a moving Windows analysis, not only in the spatial dimension, but also in the temporal dimension. So if you have, for example, yes, temperature of the days, okay, you can do it moving windows through the time, okay, and through the space. So they are very flexible. So also, you know, also these PK filter, also this one, you have plenty of, and we will see some fancy computation. PK filter dash help. You can see some really fancy computation that you can do it, okay? You can, of course, you can, you know, setting the zeta dimension, the spatial, you can do wavelength transformation through the time. For example, this one taps using spectral filtering, I never use it. So wavelength, I did it. Of course, you can also setting, probably you can set the no data during the computation, you know. You can set probably also the dash M, you can set the masking. No, this one is the polynomial, so the mask probably is not over here, but it is really dense in terms of this is Peter is an image processing guy, you know, is not just GIS in general. So he was really using for remote sensing application. So the typical, you know, when you have to do edge detection around the board to identify changing of between forest and, you know, and yes, forest and agriculture plot. So you do the change detection, the change detection, sorry, the changing of texture, so you can do different kind of filtering to identify the border of the forest between forest and agriculture field, and this is how you can do it, okay? So it's really a lot of source of information. So anyone was applying the filtering, the last, which kind of aggregation? This one for sure you were doing. Aggregation and disaggregating, moving windows. So tell me what you were doing in the last days in this kind of operation. Anyone? Anita, come on. You were doing some filtering, no? No.
I was thinking about NDVI from different dates, and you can apply Savitsi-Golay filtering or something like that to
Perfect. Yeah,
smooth.
bravo. So the Savitsi-Golay filtering is implementing over here. And actually, I think I have, yeah, Sabel filtering and Savitsky-Golay is somewhere here, probably. Yes, X and Y. No, maybe that one is in PK composite, but we have an example of field no data with the Savitsky-Golay. So
Okay.
we can have a full lecture on this one. So it's really complex, the stuff you can do it, okay? So all these operations are possible. Any other points to figure out on this?
Can one somehow use customized filters or create filters oneself and use those?
So which filter?
Can one create filters and use those as well? Is there some ways?
You say kernel filter with some weight?
No, can one create own filters?
Ah, you can create, yes. Okay, so that one, no. So in other words, Anastasia want to say, can I do, you know, can I build up my matrix where I can put weight in each single layer, for example, some fancy single, not layer, but in single cell. So that one, no, I don't think it's possible, but you can check. But I'm pretty sure it's possible in Grass. In Grass, I did it. Okay, so that one you can have an but maybe also here. Maybe it's possible also here. Wavelet family. So yeah, try to check. This is a good way of investigating if it's possible or not. Yeah. Sometimes you can combine, you know, you can getting a filter if you do the mean and then you do an operation in geographical, for example, you know. So is a matter of combining sometimes two filter, yeah, two command to get what you want. Sometimes it's not straight, but you can do it with the two action. Yeah. For example, the one before that Julia was mentioned, you have to first create an NDVI with digital calc and each single NDVI, then you can do the filtering with, sorry, the filter temporal interpolation and also the temporal field no data with, you know, with the PK composite. I can send the page that is talking about this. We had a paper on this with my PhD student. Okay, so another example that we want to share for filtering, for filter aggregation?
It's possible to remove the certain paper, the noise of the image.
Brava. So that one is called sieve, but I don't think it's over here. We need to check where it is. Maybe it's sieve, because that one, the salt and pepper, yeah, I think it's this one. The salt and pepper situation is the typical post-processing for classification, where you have only one pixel, you know, in the middle of another class. With this one, is a kind of, you know, is a kind of filter. Actually, you can do also this operation, getting the mode of your image or the majority. And this one is the majority, you know, is something somewhere here, mode, you know, the mode is the majority. So with this one, you can, yeah, majority, yeah, you can get this kind of situation. And then this one, I think is something in particular that is good to that you check it. Yeah, the raster poly with a size smaller than this will be merged. So it's kind of similar, but with a more fancy way in a term of minimal unit of land cover, something like this. So the two can be important for this kind of operation. Very good. Okay.
Okay, thank you.
Yeah. Another one that is trying to do it. Can I do this kind of filtering?
I have a question.
Yeah.
You use these DZ for spatial temporal, like operation. I'm
Sorry,
wondering,
which one? Sorry.
DZ for spatial temporal resolution operation. DZ.
No, DZ. Okay, so
DZ, yeah.
yeah. So that one
I'm wondering which kind of data you can use it for. Like, can we use Landsat? But
yeah, any data. That one are just the bands.
Okay, because I know like Landsat has 8 bands, something like that, but it's not in temporal. Maybe we should just
That doesn't matter. Doesn't matter. I mean, it's really depending from how you consider a band. So if the band are, you know, each single day is going to be the average of the days, temperature of the days. If the bands are the different spectral wavelength of the spectral signature, is going to do the mean of the spectral signature.
So then we should introduce different kind of like data for that. Like if we consider daily.
No, it's just the mean of the pixel value. So then is according to you to see if it makes sense or not. Okay, so they are just bands. Okay, so when you have a multi-band TIFF, can be spectral information, can be, you know, temperature of the days, layer of soil quality, whatever. Okay, there you have just pixel value. And in this between this band, you can do the spatial filtering, the typical one, but you can do also temporal. Probably, you know, doing between the spectral doesn't make sense. But if you think about NDVI, is nothing else than a band of two, yeah, is the combination of two bands. So if you want the mean of two, channel 2 and 3 for some reason, you can do it.
Okay, thank you.
Is it clear? I mean, they are just pixel value. Then is according to your knowledge to see if they make sense to do that operation. But these are just raster file with bands that we are operating. Okay.
I have one question. So
yes,
if we want to do an operation, but like for instance, here we were saying, imagine the mean of each 10 bands.
Yeah.
But they are okay, but it's always 10. But maybe you have a situation in which it's not always 10. Maybe you have, I don't know, I'm thinking about the days, no? If you want to aggregate it to months, maybe you have 30, 31, 28, right? You have an aggregation that is not always of the same number.
Consistent. Okay, so that one you have to make a bit of, you know, probably I would splitting with the VRT for each single month. So February 28, March 31, and then getting from this one the mean.
The other ones.
Okay.
I guess with weights it could also work, I guess, but then you'd have to be redefining the weights all the time.
Yeah, so in that case, so when you're setting the 10, it's going to be 10 all over the, you know, all over your computation.
Okay.
Okay. But if you want to do the 10 like a moving window, and then you have to do 10, the first 10 slide, 10 band, then you have to shift one and do it another 10. So you have to create a for loop that does this kind of, because now I show you for one, for one file having 10. Okay, in this case, 12 months. But if it's over, you need to keep going the for loop, okay?
Okay. Yeah, it's a matter of trying out, but splitting is of course also
and build up the loop, the bash loop that does this kind of stuff. Luca.
Okay.
Thanks. Yeah, I think my question, more a consideration connected to what Kumar said. I mean, as far as I interpret it, I mean, in the case you have multi-band images, I think there is a way that PKTOOLS can handle it. I mean, the way I measure like a Landsat, multiple Landsat images. So they're multi-band, but then it's going to create a multi-band stack of multi-band images. And then you just operate within the same band, but in different time.
Perfect.
So I think it's possible. I mean, I don't know how right now, but I think it's possible.
PK Composite is doing this. You can give Landsat image, and you can say get, let's say, the typical 4 image in 2 months, every 50 days, 4 image in 2 months. So and you say, okay, do a PK Composite using the mean is going to be band by band.
Yeah, okay.
Default. So band 1 with band 1 and band 1 and band 1. So for band 1. Then it's going to do it the same for band 2. And in the meantime, you can use it, the quality control, and say, okay, only the good pixel using the mask value. So it's really complex And there are, I will point you to web page that I built with this kind of complex system. Actually, there is an assignment on this, okay? On watching a previous lecture, okay? So it's really something that you can explore it, yeah. Okay.
Thanks.
Okay. Any other? So of course you can get quite often, you know, you are always working with the minimum maximum between you get the value, the maximum value. You are interested in the, you know, in the extreme event of temperature for, you know, the typical species distribution, plant and animal. They are affected by the extreme temperature, the coldest and the warmest, because over there is where they break their enzymatic, you know, lifestyle, biological lifestyle. So you are working with, you don't work with the mean. It's more important to work with the minimum maximum. Okay, but in the minimum maximum, you know, you can have the, you know, the out layers of the sensor. Okay, let's work with the 90 file quantile, getting, you know, the 90 file quantile of all the image and calculate the mean. So all this kind of interpolation, you can, yeah, this kind of analysis, you can do it, you know. It's a matter of combine it very well, the tools. It's not only one tools that you have to use in one shot, but maybe, you know, you can work on this aspect. Okay, very good. Okay, let's do this PK stat that is also very fancy. So because also somebody was asking me in the previous day, PK stat, you can calculate the statistic of the image. In other words, it's going to give you, be careful about this, it's going to give you an histogram of the image. So if the image is floating points, a floating value, is going to create in automatically bins, okay? And I define the number of bins by setting to 20. So over here, if you count, this will be 20. And it's counting how many, you know, how many value I have in each single bin of the image, okay? Rather, if I do it something with a binary map, then it's going to be just the, sorry, not the binary map, with a byte or integer, then it's going to be the value for each pixel. So one example. So let me see if I spot one image faster. So okay, this one, there will be probably all of them. Yeah, let's go in the dam. The dam for sure is integer. Yeah, so if I do this one, for example, and I do pk stat dash dash east dash I, so this one is going east. Okay, so it's going to, this is just a binary image. I don't know why, but we can check another one that is going to tell me how many 0 I have and how many 1 I have it. So this one, for example, if you open this image, everything is 0. You will not see this small pixel. Okay, but then if you do the minimum maximum, you will see that you have 16 pixel with value of 1. So let's try to open. Probably we will not see this one. That's why it's very important to understanding these tools, because as you see, look, it's not neither able to map it, okay, to giving a label, because there are so many. You say, okay, everything is 0. No. Let's do the histogram to understand how many 1 you have. You have 16 pixels. So, or you do it another one. This is area, so probably it's going to be floating. sorry. This is probably area. So probably it's going to be floating again, and you have the floating. So consider that if there are no pixel in the bins, it's going to list it as a 0. So let's see another one with this one. Okay, so this one. Okay, so this one is good. This is full South America. It's going to list it all the value, and be careful if there are no pixel between the range, is going to list it. Okay, also the no pixel. So in this case, you have to do another fun grep, and now you should know -v. I'm removing the 0, and you can see that you have the typical elevation file. You know, we are in the elevation design in meters, so the Ande area, South America, so you have the 6,000. So you can see that it's skewed to the left. Indeed, as soon you go down to the coastline, you have more coast than mountain area, and the pixel value increasing. Okay, so this is the histogram. It's extremely important because it really summarizes you the image in a really easy way to check and to understand what you are going to have it, and to see problems, you know. Because if you do minimum maximum, even with digital info, you get, you know, the maximum, but you don't know if it's just 1 pixel. Okay, and so okay, my maximum is just 1 pixel for some reason. So it's very important to do the histogram to check the result of your analysis. And we will see also when you do the computation and the machine learning that the extreme value are the ones that are fake the computation, they fake the classification. So use it a lot to in pre-processing and also in post-processing to understand your result. Okay. Okay, so with this one, from my side, I am complete. So so we have been covered this one. We will go a bit more down the next time. So in the meantime, you know, for Tuesday is 22 or 23? April. Okay, so it's 22. Sorry, I will adjusting the dates over here. 23, 24. Yeah, I will adjust the date. So for 2023, you can, you know, you can start to watching this lecture from the previous year. Okay, and this is the kind of Luca was asking about. Okay, so these recordings is really talking about manipulate Landsat image for temporal analysis, and we can talk about this next time and spending a bit of time. Okay. You know, and then also suggest assignment, keep working your data set by using, you know, by do all the realignment of the image, composite, and filtering, histogram. So up to now, you have all the tools to do the pre-processing of the image. Okay, so this is really the time to implementing for your study case whatever you have learned so far. So now we cover apart these few stuff that I need to show you, but is whatever we did. So it's missing few more points that we cover next time. Okay. And feel free to explore the tools. Starting actually, come next time. You have the full 5 days to really test this data and come. I was trying to do this. I didn't succeed. What we can do it. And they can give you points or command. This one can be done with this one, and then you go there and you check the details. Okay. Okay. Okay, very good. Okay, Luca, so I was point, I don't know, I was point the Landsat. over here you have the Landsat operation with all the temporal interpolation and and then there is also, yeah, the Savinsky-Colli. Somebody, yeah, Julia was asking about the Savinsky-Colli filtering. You know, you know, it's very, very dense lecture, this one, so you can start to watch it. Okay, because then we have one lecture that is a bit buffer, so we will see how it goes, because this is quite long, so it's good that you watch in advance.
But so
Okay.
there's gonna be a normal lecture next Tuesday anyway, or?
No, it's going to be a lecture.
Okay.
But
Okay.
you know, you can start watching
Mhm.
it because it's quite long, so we can do a kind of summary of the full code, because this is quite long code. So watching in advance this one, and then we can, you know, quality assessment, back and forward if something was not clear and so on. So please watch in advance. I will also remind in the Discord. Okay, and plus using all the tools to performing analysis and so on. Okay. So time to process your data with the GDAL and PKTOOLS. No excuse. Okay, bye-bye.
Thank you. Bye.
Thank you.
Thank you.
Bye.
Bye.
Ciao, bye bye.
Thank you.
Bye.
Bye.
Bye.